Hello, welcome. We are going to learn Lesson 4 from Unit 2. This is how to use the vertex form of a quadratic function. So if you'll copy down this vertex form, I'm going to talk about it. I'm going to highlight it as I discuss it, but then I'm going to undo the highlight because I don't want to keep the highlight on our notes page. Okay, so our function always starts with f of x. F of x equals a times this quantity in the parentheses, x minus h. We square that, plus k. So this is the vertex form. Notice that a, h, and k all are different colors. That means that those are usually numbers that we substitute in. So there should always be an x in our equation, and there should always be an f of x or a y. Remember also, we keep all the signs and symbols exactly the way they are when we're talking about a form, because that's a formula that we're going to use over and over again. Now, the reason why these are color-coded is because these letters have special meaning. When we have numbers in the place of h and k, the ordered pair h, k, that is the vertex. So when we're using vertex form, we can look at an equation and say, oh, I can see that the vertex is, and it'll be h, k. The next thing is x equals the value of h, and that is our axis of symmetry. So if you remember yesterday, or 2 days ago, when we learned the notes of our quadratic function, we had to use the axis of symmetry formula to find the axis of symmetry when equations are in standard form, because we can't see the h and k in standard form. But in the vertex form, we can, so we can see the axis of symmetry, so we don't have to use a formula. And then finally, A is what goes in this last line. A determines the width and the direction of the parabola. Okay, so we're going to put all this together in a minute, but why are we using this form? The vertex form shows the vertex. Remember, the vertex is the minimum or the maximum point of our parabola. Shows the vertex on a quadratic equation in respect to its parent function. We're going to write the parent function of a quadratic right here. F of x equals x squared. This is our parent function of a quadratic. Okay, now, comparing the parent function. We're going to describe how each function compares to its parent function. So remember, this is where we're looking at the values inside the function, outside the function, those transformation values. So when I have numbers on the inside, that transformation is h. Right? In our vertex form, it's inside our parentheses with our x being squared. I'm going to highlight it up here. This is what I'm referencing. So when it's inside, that's h. H determines left or right. H is left. Actually, let's be more specific. A positive h means we're going left, and a negative h means we're going right. Now we have to be very careful with that, so we're going to talk about that in a minute. What if we made those h's red, since we're color coding? Positive h and a negative h. Okay. Next, let's talk about k. K is on the outside of the function. So when I have a positive k versus a negative k, I colored in blue. Positive is up and negative is down. And remember, a is that scaling factor. So a negative a is going to flip it. And a scales is the scale factor. So these are all things to remember from when we did transformations. We've used these transformations before on linear functions. I'm going to leave it there for now. Okay, so let's describe these things. If we're describing them, we're going to describe all the different transformations that are happening. So on our first one, on number 1, we have a number outside of the x. So that is k. K is 9, so we go up 9 units. We're going to drop the units from now on. We're just going to say up 9, down 9, right or left. All right, next one, this one would be down 2, the negative symbols that we're going in the negative y direction. So we're not going to put down -2. All right. This negative out front is going to tell me that it's flipped or reflected. Let's use the word reflected. And the +5 on the inside tells me we go left 5. I'm going to zoom in so my writing's a little bit neater. Okay, our next one, we're going to describe these. We have a number on the inside and a number on the outside. So we have a shift. We're going right by 4. And we're shifting down by 1. Our next one, we have this 1/3 in front. So there's a scale factor of 1/3. So we can say scale factor. Remember, if it's a fraction, it's a compression. So it's compressed by 1/3. And the other piece is we're adding 2 on the outside, so that's a shift up by 2. Finally, we're going to look at this one. We have this negative out front, so we are reflected. We then have a 2 out front, so there's a scale factor or a stretch by 2. Next, we have this +4 on the inside, so that's a shift left by 4. All right, so that's how we describe each function. Anytime it says describe, know that that's just meaning you've got to give me in words what's happening. The words are those transformation words, up and down, left and right, a compression or a stretch, and you have to tell me by how much. All right, now let's look at, I'm going to move my scale factor over now, just so it's out of the way of the word problem. Mason graphed the parent function of a quadratic equation. So remember, that's that f of x equals x squared that we highlighted at the top. He then reflected the parabola over the x-axis and translated it 7 units up and 3 units to the right. What is the equation of the new parabola? So first thing is our parent. Told us that he graphed the parent function. So let's remind ourselves what the parent function looks like. F of x equals x squared. Now we're going to do some of these descriptions. So we're working in the opposite direction. They're giving us the descriptions we just wrote down, and we're going to put it in an equation form. So I'm going to highlight again the things that are important. He reflected it. So that is a thing. He translated it 7 units up and 3 units to the right. So there are 3 things that we have to do to this equation. A reflection means that A is negative. So my new equation is going to be f of x, my new function. I'm going to have a negative out front. It doesn't say there's a scale factor, a stretch, or a compression. So there is no number in front of x squared. But it does say we go to the right or left. So I need to open a parentheses because that means inside the parentheses, I'm adding or subtracting to x. If I'm going right, that means a -3. Now, the function has to be squared, and then it says we shift up 7, so +7 on the end. That is our new equation. All right, our next one. Give the vertex on the axis of symmetry of each function in the inequality. So remember, we're looking at what we just learned about the vertex form. There are three things in the vertex form. There is A, which is in front of your parentheses. There is H, which is on your inside of your parentheses. And then there is K on the outside. Your vertex is H comma K. So H comma K is 2 comma 3. Remember, the form has a minus in it, so I'm not taking the negative 2. I'm going to take the positive 2, the number that is in the place of H itself. So my vertex is 2 comma 3. 2 comma 3 goes in our table. Our axis of symmetry, that's our vertex. It says give the vertex and the axis of symmetry. Axis of symmetry is x equals h. So this would be x equals 2. So this is my axis of symmetry. I'm going to call it AOS. Instead of equals vertex, let's do a little colon. Save some space here. Maybe. And call it V for the vertex. AOS for axis of symmetry, V for vertex. Okay, now we're going to graph this. Remember, 3 points to the left, so 1, 0, negative 1. 3 points to the right, 3, 4, 5. Put this in your calculator, put this in Desmos, whatever you need to do to plug this in and solve each time. What are we plugging it into? Into our original function. We're replacing x each time with the x in the table. So when I plug in negative 1, I'm going to get 12. When I plug in 0, I'm going to get 7. When I plug in 1, I'm going to get 4. I'm going to get 4, 7, and 12. Remember, these numbers should repeat. Now I'm going to graph these. I always like to graph the vertex first because I know that should be the very lowest point or the very highest point, and then it should make that U shape. Remember, we're making a parabola. 2 to the right, up 3, make a point. 1 comma 4 would be on the left. 0 comma 7 would be right here. Negative 1, 12 would not be on my graph. 3 comma 4, 4 comma 7, and here would be my parabola. This isn't an inequality, so I don't have to worry about dashed lines and shading because it is a function. It has an equal sign. And there's my graph. All right, let's repeat the process. Vertex and axis of symmetry. So in this, again, we have, I don't have a parentheses around my x, so there is no h. So if I was to identify h is 0 in this equation. And k, because it's a negative and our vertex form has plus k, we had to put a negative 4 in the place of k. So h is 0 and k is 4, so my vertex is h comma k, or 0 comma negative 4. We're going to put that in the middle of our table. Our axis of symmetry is x equals the x of our vertex, so x equals 0. Negative 1, negative 2, negative 3, 1, 2, 3. We're going to plug these into the equation above. Negative 3 squared minus 4, that'd be 9 minus 4, which is 5. Negative 2 squared is 4 minus 4, which is 0. Negative 1 squared is 1, minus 4 is negative 3. This should repeat. Negative 3, 0, 5. Plot our points. 0 comma negative 4 is right here. Negative 2, 0. Negative 1, negative 3, I skipped that one. Negative 3, positive 5. 1, 2, 3, 4, 5. Okay, here are other points. And this is our graph. All right, I'm going to stop the video. We'll continue on video number 2.